In this video, we're going to study carboxylic acids. The functional group of carboxylic acids is the carboxyl functional group. The carboxyl functional group is C double bonded to O and then an OH. Carboxylic acids rank over all other organic families. Therefore, the carboxyl carbon is always C1 on a chain and no locator number is needed. So this right here only has carbon or one carbon, so we would actually call this methanoic acid. Although another name that it's well known as is formic acid, after the acid that ants excrete when they bite. This right here is ethanoic acid. There's two carbons here. This is most commonly known as acetic acid. This is the acid that's present in vinegar. This one over here is a little trickier to name, or or maybe not. You just have to remember that because this is the carboxyl group right here, I have to label this 1, 2, 3, 4, 5, 6. Okay, and then over here I've got a branch with two carbons, 1, 2. Okay, so on the second carbon I have an ethyl branch, so I'm going to say 2-ethyl hexanoic acid. Over here, I'm going to count this one as my first carbon, 1, 2, 3, 4. And notice that I have a phenoxy group on the third carbon and a hydroxy group on the fourth carbon. So I'm going to go alphabetical, and I'll say 4 hydroxy, 3 phenoxy, and then over here 1, 2, 3, 4 butanoic acid. Okay, physical properties. Carboxylic acids are organic acids. The two oxygens on the same carbon create a strong pull on the electrons of the OH bond, and the H can weakly leave as H plus in water. So we can see right here, this is my carboxyl group. The oxygens are really pulling the electrons away from the hydrogen, and therefore hydrogen can be donated. The carboxyl group gives it a polar end to the molecule, and the OH group gives hydrogen bonding. Again, the polar CO gives dipole-dipole bonding, and the R group gives additional LDFs, or London dispersion forces. So smaller carboxylic acids can dissolve in water, and carboxylic boiling points tend to be higher than corresponding alcohols. Okay, so if we look at it right here, ethanoic acid boils at 119 degrees Celsius, whereas ethanol boils at 78.4, and that's because the polar CO produces other dipole-dipole bonds, so it has stronger intermolecular forces. Dimers can also be produced as well, and dimers are basically when the carboxylic acid aligns in the following way. So the OH group aligns with the double bond O of one molecule, and its OH group aligns with the double bond O on the other molecule, and that produces what we call a dimer. Reactions. The following reaction has carboxylic acid as a product. So this is a preparation reaction of a carboxylic acid. So it only happens when we oxidize aldehydes. So let's take ethanal. So that's H3C, CH with a double bond O, and we have an oxidizing agent. Well, that right there is actually, we're adding oxygen onto the molecule, so it's an oxidation reaction. So we're going to have H3C, C double bond O, and because we're adding an oxygen, now we have OH, and so this right here is my carboxylic acid. So I'll write the names underneath. The following reactions have carboxylic acid as a reactant, so you can neutralize a carboxylic acid. So let's take a look at ethanoic acid. Ethanoic acid is H3C, C double bond O, OH, and we can react that with sodium hydroxide. You'll recall that neutralization reactions are simply double displacement reactions. So we get H3C, C double bond O, O, and that becomes negative, and the H is donated to the sodium hydroxide, and the sodium then goes on over here. So I've got my sodium right here, and then the HOH. You can see it's a double displacement reaction. And then I can write my names. Ethanoic acid, sodium hydroxide, sodium ethanoate. So the ethanoic acid ion that lacks the hydrogen, right? You can see it's the same structure, just missing a hydrogen, becomes ethanoate and sodium ion, so sodium ethanoate and water. Okay, we're going to do condensation or esterification of a carboxylic acid and an alcohol to form an ester. We'll see this reaction again in the esters portion of this unit, but just to show it, we have ethanoic acid right here, H3C, C double bond O, OH, and 1-propanol. I'll write 1-propanol like this. Okay, and what happens here is the OH group of this will come off, and the H of this will come off. And so as you probably have gathered, H and OH come off, so then we have HOH. But over here, I still preserve this structure, H3C, C double bond O, and then I have to join it to the oxygen of the alcohol, and then CH2, CH2, CH3, right there. So we can see that the H and the OH are off, but now I have this big molecule right here, and that's why it's called a condensation reaction. We're taking two molecules and we are putting them together to form one molecule. Let's write the names underneath. So over here, I have, well, first of all, I've got ethanoic acid, 1-propanol, and water. This one's a little tricky right here because it's an ester. We're going to talk about how to name this in the next lesson, but we'll just give you a little preview. This portion came from the alcohol right here, and I've got 1, 2, 3 carbons that came from the alcohol. So I'm going to say propyl, and then I create a space, and now I've got 2 carbons from the acid, so then propyl space ethanoate. Okay, alcohol comes first, then carboxylic acid. There is another condensation reaction, amidification of a carboxylic acid and an amine to form an amide, but we'll look at that in the amide note. Okay, so that's it for carboxylic acids.